Hello guys, welcome to Ramta Solutions. Welcome to your differentiation calculus exam prep series. Today's video looks at Maths Paper 1 by the National Department of Basic Education's November 2024 exams. So guys, you know that it's important when you get to your exams to always read your instructions. All of these instructions are important, all of them. I would like to read a few. For example, instruction number 4 that says, clearly show all calculations, diagrams, graphs, etc. that you have used in determining your answers. Instruction 5, answers only will not necessarily be awarded full marks. And then instruction number 7, if necessary, round off answers to 2 decimal places unless stated otherwise. So a further tip on this is that in the middle of your calculations, if you happen to have decimals, perhaps keep your answer to 4 decimal places and only round off the final answer to 2 decimal places. And of course, if you happen to forget your formulas, instruction number 9, of information sheet, an information sheet with formulas is included at the end of this question paper. And lastly, in as much as you are working for distinctions, also try to improve your handwriting. Let's try to have a neat and legible handwriting. I know it is subjective, but let's try to improve that. I know that working on your handwriting is a very slow process, but try to improve it, of course, improving your pace as well. Okay, so we are looking at differentiation calculus. It is normally question 8, and I want to tell you this. This is an exam, so an important tip is this. For every mark, you should spend a minute. For example, our question 8, you should ensure that you spend about 18 minutes on it. So with regard to this video, at 20 minutes, we should be done with this question. So let's proceed. 8.1.1, determine dx of 3x minus 5x squared. With this one, before you differentiate, you must make sure that you simplify the term inside the brackets. If the term does not need simplification, differentiate. So this does not need any simplification, so we will differentiate. This becomes 3, the power here is 1, 3 times 1, x, and then it'll be 1 minus 1. This is 5, we drop the power, which multiplies 5 by 2, and then it'll be x to the power 2 minus 1. Then what is this? 3 times 1 is 3, 1 minus 1 is 0, 5 times 2 is 10, so this is minus 10x, 2 minus 1 is 1. So this, we know 3 to the 0, or rather, anything to the 0 is 1. So x to the 0 is 1. So we are left with 3 minus 10x. Note, this is not really important. I just did this to help you differentiate. Okay, if you're struggling with differentiation, this is how you roll. Okay, cool. Proceeding, 8.1.2 says find or determine g prime x if g of x is equal to 2 over x squared minus cube root of x to the 7. So we need to simplify this. At this level, you don't know how to differentiate something like this. So we will rather say 2x to the minus 2 minus x to the 7 over 3. If you're wondering why I said x to the 7 over 3, it's because a cube root is basically a power of 1 over 3. So x to the 7 multiplied by power 1 over 3, this will be 7 times 1 over 3, isn't it? Hence, we have 7 over 3. Happy? Perfect. Now, we can differentiate. As you can see, we did simplify the expression. So, This then becomes 2. You drop the power, which is minus 2. All right. X to the minus 2 minus 1 minus, you drop the power, it's positive 7 over 3. And then you minus 1 in the power. So this is minus 4, right? This is minus 4x to the minus 3 minus 7 over 3. 7 over 3 minus 1 is 4 over 3, isn't it? So we can leave it here. It's okay to leave it here. Okay. It's okay to leave it here. All right. So we are on the right track. Let's proceed. 8.2. Determine the equation of a tangent to f of x equals x cubed minus 4x squared plus 2x plus 3 at x equals 2. So let's find the derivative, which is f prime x. We're not going to use first principles. We'll just use differentiation rules. By now you know how to differentiate, guys, right? So allow me to just go straight away. It'll be 3 minus 1 will be 2, and then it'll be 4. Dropping the 2, 4 times 2 will be 8, and then 2 minus 1 is 1. Dropping the 1, it'll be 2 times 1, it's 2. Now 1 minus 1 is 0, x to the 0 is 1. Derivative of a constant is 0. So this is f prime. However, gradient at a point, okay, now we're saying a gradient at a point, okay, a gradient at a point, what point? At a point x equals 2. Therefore, we need f prime of 2 will be 3 times 2 squared minus 8 times 2 plus 2, right? So what is this now? So this becomes, let's see, this becomes 12 minus 16 plus 2. So our answer should be minus 2. This is gradient at a point. All right. So y value of the point, okay, y value of the point will be, y value of the point will be f of 2, which is 2 cubed minus 4 times 2 squared plus 2 times 2 plus 3. Okay, plus 3. Now, what is our answer? Let's see what our answer is. So, our answer will be, ooh, 8, and this is 16, 8, 12, 15. So this must be minus 1, isn't it? This must be minus 1. So this is minus 1. Therefore, the point is 2 and negative 1. So equation of tangent, oops. Now equation of the tangent will be, so I want you guys to realize something here. We didn't have the y value of the tangent. We can have, the y value at the point of contact, right? We only have the x value. We can find it by substituting the x value into the f of x. Now we know the equation y equals mx plus c, isn't it? And then the point is 2 and negative 1. Where there's y, we put negative 1. Where there's x, we put 2. So this is negative 1 equals the gradient. We calculated it to be negative 2. So it's negative 2. Where there's x, we put 2 plus c. Therefore, c is equal to 3. Therefore, we can say the tangent has the equation negative 2x plus 3. Okay, the tangent has the equation negative 2x plus 3. Okay, perfect. Now proceeding, let's then head to question 8.3. Question 8.3. Remember, guys, we should be done with this at the 20th minute. Let's see. Given f of x is equal to negative 6x squared, 8.3.1, determine f prime x from first principles. Okay, first principles, f of x equals negative 6x squared. F of x plus h will be negative 6 times x plus h. Remember, this means where there's x, you put x plus h. Minus 6, let's see, simplifying this, it will be x squared plus 2xh plus h squared. Right? Great. Now we know first principles has the formula f prime x is equal to the limit as h tends to 0 of f of x plus h minus f of x all over h. This formula is given in the formula sheet. Let's see, where is it? Here is it. Do you see that? It is given in your formula sheet. Okay, great. Now proceeding. Let's see now. We said f of x plus h. Ooh, we should also further simplify this. It will be minus 6x squared minus 12xh minus 6h squared. Okay, good. So what is f of x plus h? It is minus 6x squared. Oh boy, let me go back to the black color. It is minus 6x squared minus 12xh minus 6h squared minus, what is f of x? F of x was minus 6x squared, right? Minus 6x squared all over h, right? All over h. So we cannot substitute the value of h as yet, because if we do, we are basically saying where does h, we put 0. It will make this infinite, right? Not infinite, but invalid. Okay, so we cannot. Let's simplify the expression first. A limit as h tends to 0 of this part here, we will be left with minus 12xh minus 6h squared all over h. Remember, minus 6x squared minus 6x squared. It will be minus 6x squared plus 6x squared, which is 0. Right? Good. So now we need to collect the like term, but be careful here. Again, at this point, you cannot substitute h equals 0 because it will give you a denominator of 0, which will be invalid. So again, we will factorize. When we factorize, I know we can say our common factor is 6h. But now, the aim here is to get rid of the h in the denominator. So let's just take the h out. So we are left with h. We are left with minus 12x minus 6h all over h. Right? Good. Again, as you can see, the h's are cancelling. You're left with minus 12x minus 6h. Now, at this point, you can substitute where there's h, you can put 0. And when you do that, you remove the limit. So you have minus 12x minus 6, open bracket. Where there's x, you put 0. Proceeding, you therefore say you have minus 12x. And this is your answer. You could have gotten this answer even without performing first principles, right? You can see that using differentiation rules, this is minus 12x, right? Cool. Okay, let's proceed. Proceeding 8.3.2. 8.3.2, they say write down how you will restrict the domain of f such that f inverse, the inverse of f is a function. Remember, for you to do this, you simply say x must be greater or equal to 0, or you can also say x must be less or equal to 0, whichever you choose. Remember, the reason I'm saying that is because this is a frowning parabola. It will look like this. Right? It will look like this. Right? It will look like this. So you have to think of ways in which you can make this work. So in order for you to make it work, when you say x is greater than 0, it means you're only looking at this arm. When you say x is less or equal to, you're only looking at this arm. Okay? And this is it. You only need to write one of them. As you can see, it's 1 mark. Right? Good. So let's see. Are we still on time? We will see. Now, 8.3.3 says determine the equation of F inverse for which this is less or equal to, or F inverse is less or equal to 0. Write your answer in the form whatever. So I will say y is equal to negative 6x squared. I like saying y equals x as an instruction, highlighting it. Where there's y, you put x, and where there's x, you put y. Right? So dividing by negative 6 throughout, we'll have negative x over 6 equals y squared. Then square root, it'll be negative x over 6 plus minus negative square root of negative x over 6 equals y. So remember here they say that where the inverse is less or equal to 0. So if they say where the inverse is less or equal to 0, you therefore say it means the y value is negative. So it means they say y is equal to negative, right? They gave you that thingy. Okay. They gave you that thing. And you should remember here the restriction for this to work, x must be less or equal to 0. Okay. For this to work, x must be less or equal to 0. Okay. All right. So this is how you answer this question. So let's see. We were able to finish this question in less than 18 minutes. And in fact, the actual minutes were 17. On your screen, it's 17 minutes, but I think we finished it in like 15. So we saved 3 minutes. Do you see that? And this is how you attempt your exams. Okay. Happy? Great. Now let's go to question 9. Let's go to question 9. So with question 9, let's see what question 9 has for us. So question 9 says A with coordinates 1 and 9 and B with coordinates 5 over 2 and 8 are the turning points of the graph of F below. C with coordinates 0 and 7 is the y-intercept of F. Cool. Now, the question is asking you 9.1. It's asking for which values of x is F decreasing. Now check this out. To the right of x equals 1, we can say the function is increasing. To the left, not to the right. And to the right of x equals 5 over 2, it's also increasing. Your function is only decreasing at this level where we say this is when x is greater than 1 but less than 5 over 2. Okay. This is the only region where the graph is. All right. Okay. Now, proceeding. Now let's proceed. 9.9.2. And by the way, we should be done with this question in 8 minutes. Okay. We should be done with this question in 8 minutes. Okay. So let's see. 9.2, write down the value or values of the x-intercepts of f, the derivative of f. So the x-intercepts, we know what they are. What are they? The x-intercepts of the first derivative are the x values of the turning point. So they are x equals 1 or x equals 5 over 2. If you like, you can say 1 and 0 and 5 over 2 and 0. These are the x-intercepts of first derivative, isn't it? This you know. All right. 9.3. For which value or values of x will f be concave up. For it to be concave up, it must be in this region. So we need the point of inflection. Okay, so we will need to find the midpoint. Remember, the point of inflection is the midpoint of the turning point, right? So we will say x equals x of a plus x of b all over 2, which is, what is x of a? 1 plus 5 over 2 all over 3. So what is this? Is it so? Yes, it is. So what is this? So when you look at this, this is 6 over 2. It's 3. 6 over 2. It's 3. What is our answer? 6 over, okay, 7 over 4. Is it? Yeah. Oh, it's 7 over 2. 7 over 2. So this is 7 over 4. Now, this point here, the point of inflection is 7 over 4. So for it to be concave up, the x values must be greater than the point of inflection. Therefore, this is when x is greater than 7 over 4. Okay, let me just say this. Therefore, concave up when x is greater than 7 over 4. Okay, all right. Now, 9.4, determine the value or values of k for which for which y equals f of x plus k will have 3 positive x-intercepts. For it to have 3 positive x-intercepts, wow, this is very interesting. This is very interesting. So remember, right now you do not know the equation, right? The equation has not been given in any way, isn't it? The equation has not been given fully, but you will need to manipulate this. So when you manipulate this, I would like you to do this. Remember, this point is 7. If you shift the graph, okay, if you shift the graph downwards, okay, I want you to shift the graph downwards, ne? By try to shift it 7 units down. If you shift it 7 units down, you will have only one x-intercept at 0. It will not work, right? So therefore, I'm urging that you shift it more than 7 units. So if you shift it, say 8 units, because normally for you to have 3 intercepts, you will need to put your ruler like this and say add, say k equals 8. You can have how many values? 2 y values. Can you see that? And then at k equals, let's say you put it here, it'll be, let's say 9. You see, it'll be 2 x values. So this region here is the one that we are interested in. So in order for this to really work, we must try to shift this. Do not shift it 8 units down. If you shift it 8 units down, this point will be at the x-axis. So try to shift it 9 units down. Okay, try to shift it 9 units down. So try to shift it 9 units down and 8 units. At most it should be 9 units down. Yeah, at most it should be 9 units down. Okay, at most it should be 9 units down. So what I can therefore say, I can say try shift the graph downwards. Okay, so when you shift it downwards, I prefer to say let your k be greater than, should I even say greater? Okay, it's fine, greater than 9 but less than negative 8. Okay, but less than negative 8. If you shift it like that, you will possibly have, because you can see the distance between these 2 points is only 1 vertical unit. So it's okay like this. Okay, so any decimal you can think of will give you 3 positive x-intercepts, and by so doing you are good. Okay, so this is your answer. Okay, this is your answer. Remember, I said shifting 7 units down will not really work. Shifting 8 units down will not really work. But if you shift it 9 units down, it'll work. So try to shift it, try to make k a -9 and -8 because you're shifting the graph downwards. Okay, so we are good. We are okay. We are done. Now let's go to question 10. So let's see question 10. So question 10, we must be done with it in 8 minutes. Let's see. So it says a cyclist rode from town P and stopped at town T. The speed in kilometers per hour in which this cyclist rode is represented by the equation s prime of t is equal to -3 squared plus 18t. This is the speed. Remember, the speed, if s prime t is the speed, okay, if s prime t is the speed, it means st is the distance, and then s double prime of t is the acceleration. Okay, is the acceleration. Please note this, but let's get into the question. Note, speed is the rate of change in distance with respect to time. Cool. If you do physical sciences, you are at an advantage here. All right. Calculate the maximum speed that the cyclist reached on his side. No worries. I will try to, for me, I will use, because this is a quadratic, I will complete a square. Okay, I will complete a square. If you like, you can also try to equate this to 0 and use second derivative. Okay, so let's see. They say calculate the maximum speed. Okay, calculate the maximum speed. So I will say completing a square, take -3 as a common factor. I'm left with t squared minus 6t. Now I'm completing a square, so it'll be t squared minus 6t plus half of -6 is -3. Repeating the very same thing. All right. Okay. So what do we have? We have -3, perfect square trinomial. This is t minus 3 close square minus 9. Okay. Now this is -3 open bracket t minus 3 close square plus 27. All right. As you can see, this is a frowning parabola. All right. This is a frowning parabola, and this is the value of q. This is the maximum. Therefore, maximum speed. Okay. Maximum speed is 27. They said in what? Kilometers per hour. 27 kilometers per hour. Okay, 27 kilometers per hour. All right, good. 10.2. 10.2, let's see now what 10.2 has for us. Okay, so 10.2, it says we must now calculate the distance between town P and town T. Ooh, this will be interesting. This will be very, very interesting. Okay, but not to worry, we've got this, isn't it? We've got this. So let's get into it. Let's see what we can do. So what we can do now is, let's see. I'm going to advise that we do this first and first. Let's try to find the x values. Okay, so at which we have a minimum and a maximum. So we will say s prime of t equals 0. So let's solve. S prime of t, what was it? It was -3 t squared plus 18 t equals 0. So common factor -3, -3t, we are left with t minus 6 equals 0. As you can see, t equals 0 or t equals 6, all right? Or t equals 6, isn't it? So now what you should also be asking yourself is this. what you normally know is that S of t is basically at cubed, right, plus bt squared plus ct plus d. But we don't really need the d right now, because as you can see, first derivative set, the t part, when you differentiate this, it became 0. All right, it became 0, isn't it? So this means this c was a constant. Okay, so let's see now. What is the, when you look at this s of t, from this equation, we had negative 3t. So it means we had negative, we had what? We had negative t cubed. And what is this? 18. So we must have had 9t squared, right? Plus c. This must have been the distance formula, okay, or the distance equation. It must have been like this. Okay, remember guys, if you differentiate this, say s prime t, you will get negative 3t squared plus 18t, and this is a constant. It becomes 0, which is something that you had here. All right, good. Now let's see. When we head to s of 0, it will not really help us. So s of 0 will be c. All right, this is equation 1. And then s of 6, where there's t, we put 6, it'll be minus 6 cubed plus 9 into square plus c. What do we get? 6 cubed will be 216. 216 plus minus 9 times 36 will be minus 108, isn't it? It's plus 108. In fact, it's 108. All right, it's 108 plus c. So this is equation 2. So equation 2 minus equation 1. What is this? We therefore say we're looking for the distance between pt. So we can therefore say pt is 108 plus c minus c. Therefore, it is 108 kilometers. The distance between the two towns is 108 kilometers. Happy? Great stuff. And this is how you answer your differentiation calculus questions. There are many ways to answering your questions. Whichever you are comfortable with, go ahead and use it. All right. All right, guys. Remember, if you would like to get in touch with us, visit our website, www.adultasolutions.co.za. And in the description of this video, you are probably watching on YouTube. In the description of this video, links to different social media platforms will be given. And so is if you're looking for a tutor, you can contact us on any medium you prefer, even on WhatsApp. So with that being said, it's a wrap. See you next time. Bye-bye.